Good morning, everybody. How's it going? For me, it's going okay. I hope everybody's doing good. If you're in the Discord, you would have seen Ray's chat last night, but winter has officially arrived in Canada, especially in our parts. So, snow, rain, cold. Not quite as cold as it's gonna get though. There's supposed to be a what do they call it? A polar vortex coming our way, which is gonna be amazing. Those things are the best. Anyway, morning. I hope y'all are well. As you can see, just me this fine day. Stig has 9C and rain today. See, we didn't even have a break, Stig. We literally were 20 degrees on Friday or Thursday, and then it was like, I'm gonna be mild today, and then snow. Like it was like we just shifted gears. I'm hoping we flip back a bit, but it's not uncommon here on Halloween to actually like just have to put snowsuits on and throw your costumes over them. Poor kids, you do all that work and you don't get to show off their costumes. So yes, Greg, as you all probably can see, is not here. Oh, he's under the weather. So 75 in Chicago. I used to know how to do that math. Google will do it for me. 75. I think you divide it by 2 or something. I don't know. Fahrenheit NC. Go Google. 23. That's pretty good. 75 is warm, y'all. That's what it means. We had sun and 18 degrees the other day. The next day was 7 and foggy. Yeah, we're just getting into those hard swings now, eh? It's like, especially where we are, it's there's 3 seasons really, right? There's winter / what's supposed to be fall / what's supposed to be spring, and then fire season. And I mean, like, you get those 3 amalgamated. It's great. Yeah, sorry, we don't understand C. we're not accustomed to not reading centigrade. That's fine though. We'll figure it out. We have Google for that. So as a lot of you know, I was at a conference, and Greg was supposed to be there, but sadly he was not, which is okay. But we did a conference, and it was 2 weeks ago now. It was for education. So the big thing about this conference, though, was it was the first one that we actually had in the last 3 years since COVID, right? So everybody was there. You got your name tag, little sticker on your name tag to say, hey, you can come shake my hand or stay back. I don't want to have you near me, Typhoid Mary, sort of thing. It was a good conference. One thing I noticed was there were a few booths that actually had 3D printers. It's been a while since I've seen a 3D printer at that particular conference. They were really big, maybe 7 years ago there, but there was 3D printers there. And lots of people were excited about 3D printing. We did our 3D printing, well, we did our 3D printing in education workshop stuff. So I'll show you what all that looked like, but like just an overview. But we did it. One thing that wasn't talked about though, the whole time, is kind of the idea, I guess, of this, and you guys will have good input, I know. Before we dive deeper into topic for today, I'm going to just flip this over here and say a big thank you to all the people on this list. I rebuilt it so it was correct. So thanks Helge up top. Thanks everybody else on the dissolvable supports. And we don't have any build plate guys anymore because they moved on up. They're moving on up. See, it's just enough not to get copyright struck. So that's okay. So one thing that we missed a lot of when we were talking, especially, I won't say me particularly, like our session is pretty good at mentioning it, but vendors they always what's the word I'm looking for? They always probably, let's call it, evangelize their product. Vendors are there to sell you stuff. It's the truth, right? A company wants to sell you their next thing, right? If we all want a new printer and we go, hey, what's the newest thing out there right now? I'm going to buy a new printer. I might as well get that, right? You go on, you look at, let's say, Anchor's site as an example, and you see their new printer, and a little bubble pops up in the corner, boop, and then it goes, hey, do you want to buy my printer? You should buy this. And you go, well, I'm not sure. Is it good? Of course it's good. It's the best printer on the planet. You should buy it, right? So like the sales guys are doing their sales thing. Even the sales bots are doing their sales thing. And I'm not saying salespeople are bad. I used to be one. I'm saying that their main goal in life is to get you to buy something, right? And so they will glass over certain problems with a product to sell you it, right? I mean, we can all put our hand up in chat when how many people bought like original Big Tree Tech boards on the week they released, right? So like think SKR 1.4 or the new E3, not new anymore, but when it was new, E3 Turbo, or Octopus, right? When those boards first came out, everybody's in line, hey, does this work? And they're like, of course it works. Look at all these people we sent. We've got backers out there, and we've got we sent all these demos out to all these YouTubers, and they're doing this, and look, this is just perfect. And then you get yours, and turns out you have to unsolder some resistors or drop an EEPROM or whatever it is, right? And I'm not saying the vendors are being like malicious, because they're there to sell a product. In some cases QC's not there, but oh yeah, Stig says I don't buy bleeding edge stuff, and you know what, neither do I most times, and that's a lie. That's a direct lie. But generally speaking, I will wait till there's some research out on it, and then I over research it, and then I'll buy it. Now where I'm getting at with this whole kind of vendor thing is 3D printers. When we look at like the overall space of 3D printers, there's not a lot of change in the last a long time, right? As soon as that i3 Mega frame came out, we have extruders that push through hot ends that give us prints. That's it, right? We've modified the technology a little bit to do like non-planar printing, so you can print overhangs where you shouldn't have been able to print overhangs, or smooth tops, right? Ironically speaking, one of the new, quote unquote, new technologies that are, kind of taking the world by storm are those resin 3D printers. How many people here have resin? I do. I know I do. I thought Stig did maybe, but I'm just curious if you guys have resin. Just so you know, I got the Discord chat open too. So if you want to pop stuff in the Discord, I can see it as well. So if you have links and or pictures and stuff. But resin has been taking the lead right now. I actually saw who was it? Elegoo has like a new, they call it like a Carbon Tough, I think was the name of it. But like it's a new resin, and like they were printing the use case for that one was they were printing buckles for like snowshoe harness, boot buckle kind of things, and it's strong enough for that. So I mean, resin is getting more, resin's getting popular, but I agree with Stig's statement in the chat there. I stay away from it until I really, really need it. Now there's a plethora of reasons for that, right? Like it's hard. It's not hard to print. It's easy to print. It's hard to handle because there are some safety things you have to do, right? Glove up, mask up. Resin is one of the only filaments you'll get that has like a link on the side to its material safety data sheet. I don't know if it might be that internationally. I don't know. I don't know if that's an international standard or not, but in North America here, we have material safety data sheets, and they tell us, ooh, this resin's really bad if you drink it, and if you get it on your skin, it's really bad, and if you look at the bottle funny, it's really bad. But when we look at like advances in 3D printing, like Resin is it was a few years back, maybe 3 or 4, and yeah, resin was taken off like a bandit. But like both these technologies have been around since 70s and 80s. It's just we're seeing them as consumers, right? When you think about Dom says, I live in an apartment. If I get a resin printer, I'll have to put it in the bathroom. Oh, you'd have to put it on the balcony or something, man. Or you'd have to put in like a HVAC that has like capable of circulating your room every second. Like it's that's you, yeah, it's not good. Yeah, and Stig says, I've been around enough toxic chemicals to avoid them when I can. I agree, right? Like, we're all exposed to things in our daily life, at work or, at play, that we don't need to add to that. Anyway, resin's there. It's not new. it's an old technology. But again, it's one of those things that comes with the MSDS, and it's if you need to do it, you can do it. Now, where am I going with this? I want to talk about sustainability in our hobby, and where it's going. And I think to do that, we have to understand a little bit about how fast technology has changed around 3D printing, and where 3D printing has kind of been this, 10-year kind of, static course. We have filament, we have resin, we put the filament in the hot end, it goes out, we put the resin in the vat, it pulls it up, and that stuff, right? Up until now, we've been happy to print and print and print and print and print and print. And I'm not saying we're still not happy to print. We all love printing. That's why we're here. What happens after, right? So when we print, we know for a fact, and you can see it over my shoulder here. It's in frame for a reason. That right there. That garbage can. I will fill that garbage can probably every month or month and a half with supports, failed prints, failed tries, prototypes that I don't need anymore, right? And it gets full. And it gets full of every material in this room right now. So it gets full of PLA, ABS, and it gets full of PETG, PETD, some sort of PET. And when you get that situation going on and you're throwing, like, literally, I don't know how many of people live by a place that has kind of like a recycler for these kinds of plastics once they've been used, right? Because you can't just take your bag of PETG into a bottle depot here and say, hey, this is all the same plastic, trust me, just recycle this. It doesn't work like that, right? The recyclers here will send bottles back to plants, they'll melt them, right, whatever, but they won't take random plastics in a bag, which is fair, right? Like, why would you take a random bag from somebody and go, okie silly dokie, well, I'll recycle that for you? It won't happen. So my bin behind me there usually gets all sorts of plastics in it. And then I run into the issue of, okay, if I need to recycle these plastics, what do I do, right? And we've talked about a little before of how you can get rid of like PLA, for example. And PLA is compostable kind of at home, but like it needs an environment that is wet, warm, and microbe rich. So when we look at, there it is. So when we look at, so this is just, I got a couple things from All3DP and a few other sites today, but you can see this is like a PLA bottle, and it kind of shows how it's being biodegraded, or composted, as you will. So I want to draw our attention to this statement down here, though. So like, that's a neat picture, right? It's like, look, there's plastic, less plastic, less plastic, and then we swept it up because it was just garbage. So let's blip, blip, blip. There we go. So the last statement there, PLA is not compostable in the formal sense of the word. So if you have municipally composting, don't mix your PLA in, that kind of stuff. The PLA can take longer than a year in normal circumstances with a microbe-rich environment, with the right heat, with the right moisture. This picture up here is done inside of a plant, right? It's a recycler. So like I know we have one north of us here in one of our bigger centers in Calgary that can do something similar to this, but this is a recycler. And the reason this works is because PLA is it's produced via corn, starch that's worked on obviously to make it into a plastomer. But when we look at like PLA versus PETG, I mean, this is where we can start talking sustainable in 3D printing. So PLA as a printing material for prototyping is a good idea. One, because it's renewable, right? I mean, if you can make it from corn, all you need to do is find a corn crop. But that being renewable is questionable too, because over the last 3 years, I live in basically a corn producing valley, and we've had hail wipe out 2 years, I think, out of 3 now of all the corn, right? So like that being renewable, yes, we can grow it, but is it going to last? That's the question, right? The other thing that we can talk about too is PLA has a smaller carbon footprint, right? So PETG is made from fossil fuel, oil, whatever, right? So getting that is a lot harder. Now there is bioplastics like BMLA and stuff like that that's close to PLA now too. And they're made from renewable sources that can decompose. There's filaments that are obviously made of other materials too that aren't 100% plastic. We're not bringing those into this conversation. I just want to talk plastics, right? ABS, PET, and PLA. And of those 3, ABS is obviously the hardest and worst because it just sits there. It doesn't go anywhere. PET, again, it doesn't like biodegrade, but it is recyclable. So PET in its form, so think like cups and stuff like that, PET can actually, you can reuse the cup for a long time. That's one way of reducing the waste, right? You can reuse, and we're going to come to that in a second. The other thing is with PET, if you're going to have something that's in use for a very long time, it's a good option, right? Because we know PLA has creep as a material if you're using it to print brackets or strong pieces. PET might be the option there just for longevity. And then the last thing is, I mean, I mentioned it before, but technically you can recycle. You can recycle PLA and compost it. Where you can recycle both. And recycling is an interesting word because I don't know how many people here have like local recycling programs. So like where I live, we have a green or a blue bin for our garbage at home that we can throw our cardboard and plastic into, and then we're getting a green bin that technically you could put the PLA into, but I'm sure they would yell at you for doing it. And then, just a regular trash bin. And when you do that, your your bins go longer, right? We have bottle recycling up here too. It's always weird when I go to places and travel. So like when we go to the Dominican on vacation, you have your pop bottle, which I have to have my pops, right? You guys know that. But when you're wandering around, there's only garbage cans, and then you notice that these bottles are going into the garbage cans, and I go, that's weird, right? But like there's some statistics on how many of the bottles and things you actually bring back to recycle get recycled, right? Same thing with electronics recycling. Once they get your recycling material, they basically melt it off and smelt everything off in the worst fashion possible to get all the precious metals and anything that they can reuse. And then there is a portion that's literally just getting thrown in the bin. The compost plan says compostable utensils take twice as long and have to be run through twice. Yeah, so that's a good example, Gary. Yeah, and those compostable utensils, generally speaking, now are PLA, so they have to go through twice to actually get them down. And I mean, if you had like ABS, they would just keep going forever. So I guess twice is okay, but we have a big issue globally, even with plastics, right? Like there's off of our west coast, in between Japan and us, there's that floating mass of plastic that's as big as an island now, right? I don't. There was a news story last week where we as people are starting to consume microplastics through just our drinking water. Rainwater isn't safe, that kind of stuff. So what can we do as 3D and printing enthusiasts to help with this problem? And there's been some solutions. Let's call them solutions. There's been some stuff that's come up over the years, and I want to take you down memory lane here for a second, and then I know we've talked about the one, but there are filament re-extruders, and I have a couple pages here with them. But if you haven't seen these, stop me, and then I'll be like, oh yeah, check it out. So basically, you can get these filament extruder kits, okay? And again, if you haven't seen what these are, just like yell stop in the chat, and we'll go through it. So there's a few different kinds. You can definitely DIY one for yourself. Not Stefan, but his cohort. I can't remember now. I'll have to remember his name, but you can build your own, and he did. You can. Most of them, so let's see, most of them come kind of like in this pre-built sort of kitty form, and you can see at the front of the unit there, you'll put in PLA up top, and the idea here is you can take your old PLA and get a plastic grinder, right? And those can cost anywhere from like the cost of a blender if you wanted to try it. I know people use it. Or you could get like an industrial grinder that either has a motor or a hand crank that just chews up the plastic. You got to get the plastic to about like 4 mil or 3 mil diameter. It doesn't have to be a sphere, but it would be really hard to get it into a pellet or a sphere. So you crush your plastic, you throw the plastic in here, and then this little machine has a stepper motor that pushes the plastic out and along. And then the idea is you take the output of this, and then you'll hook it to a spool, and usually your spool will be on an auto turner, and as it's turning, this is extruding, and basically as you're pulling that filament, you're going to pull it to a 1.7 or 2.85 diameter, and then hook it on, and then it will spool filament. These work. I mean, do they all work? No. But do most of them work? Yes. Do they work as good as you ever think they're gonna work? Probably not. So this one's about $3,000, right? And you look at it and you go, but it's an insulated hot end and like an auger. And yeah, so this is one of the packs, and this is Philibot. I've seen these around for a while, and they work okay. I don't know if these are all variants now. But again, hopper material in the top. You can see this one extrudes into like a geared fitting, so you can pull and tension the filament instead of like using your filament system. Now, these aren't perfect, okay? I'm gonna, like, this one's $600 to $700, but these are not perfect. So like for most of us, and Stig just said it too, but for most of us, we can buy filament for like $30 or less, right? Before the pandemic, it was like 25 or less, and well, we all know how after has been working out so well for all of us. So these things do work. Dominic says at Earth there was something that made PET filament from bottles. Hey, no spoilers. That's on another tab. I'll look at it in a second. So these ones basically take into account that you're going to be giving it some sort of crushed output plastic, and you can't mix plastics, right? So if you have a bin like I do where I put like my recycling and stuff, you have to make sure that you have different bins, right? You want your PLA separate from your ABS. You want your filled PLA, so wood, metal, that kind of stuff, different, right? So now here's the thing. This, I've seen this one work too from 3Devo on Devin Montez's channel. Brain's going away on me, but his name is Devin Montez. I remembered that. But you can see this one is designed to take pellets, right? So this, and you can put recycled material through, but the pellets with the PLA works better in this particular model. But let's look at the price, $7,500, right? So again, back to Stig's point for a second. All of these do work. They've been around for a while. This is like a $4,000 one. Same thing. Filament in, crushed, move it out, whatever, and you're done. So some of them can take more. Like I saw the first one up there that was 5,000 can take PEEK and other materials like that. But you can see here, they get pretty simple. And the idea is, and Gary brings up the point, how do you make sure that your diameter is 1.75 and consistent, right? I mean, I definitely changed how you type that question, Gary. Sorry. The answer is most of these do have a sensor, and I'm going to flip to another page in a second, but you can see here, this is kind of like this is the do-it-yourself way. It's $600. So if you are good at Arduino and you are good at engineering a little bit of a rig, you can do it. So here you can see on the right, that's our hopper. So we put all our stuff in there, and as it goes through there, it heats up into that hot end, and then it goes over the fan, and the fan is what's cooling. So if you guys have seen 3D Printing Nerd did a tour of the Prusa factory, like when they opened their new factory, and they did a tour of the filament part. And when they cool actual filament, it goes through water. So instead of a fan, it goes through water, and then that cools it. So basically what happens is, as you're extruding it, it's cooling it, and it's going into that next part right here. And in here, there's a sensor generally, or some sort of gauge, a magnetic sometimes gauge, or an optical gauge, depending on how the switching works in them. But that's supposed to tell this controller box that yes, my filament is coming out at 1.75, keep the feed rate constant here. Or you know what, it's slightly smaller than 175, so I need you to speed up to add more material, or slow down to take away material. And then eventually the idea is, after calibrating it a little bit, you'll get a constant flow, and then that's when you can hook it on to your spool. Now, this is all well and great. I think these are good, but I'm going to circle back to Stig's comment. They're a little on the pricey side. They're a little time consuming compared to like just going buying a spool from your favorite filament place, mine is Spool 3D. And I also enjoy Amazon, and I do a lot of there's a store out east that carries Filamentum and stuff like that for me, and I enjoy that filament. So that takes less time than like gathering all your recycled stuff and then grinding it up, right? Now, not to say that people haven't automated the process, because you can just like grind it straight into the hopper and away it goes. But I want to point out a flaw, not a flaw, but it's a logic point here. When you look at that hopper, right, and you're like, well, hey, I could fit a spool in that hopper, right? Easy. But you got to keep into consideration that when you're doing this and you have to shred the filament and like grind it all up, right? You have to keep in mind that you're going to have air between it. So you might have to recycle 4 of those hoppers in order to get like one roll of filament. Now, when you think of, and I'm not going to quite go to the bottle thing yet. We're getting there. And so this model is sort of like how to recycle your filament into filament. You grind it, you put it in the hopper, the filament go in, filament come out. It's in the true sense. Now, this is the other way. And lots of people who do molding and stuff, I've seen quite a few people online do similar things with like serving trays and stuff with other plastics that like are higher heat than PLA, but you can make objects, right? So this is a solid casted stool, right? So when you look at it, there's other ways you can reuse them, right? You can melt this plastic into molds, right? So you can make silicone molds or buy them, right? And then you could mold the used plastic and it looks kind of cool, like sort of. I mean, this chair is straight out of the 60s. But like this is a way you can reuse it, right? And you can see here, it's just showing us those machines again. The article above it is actually like their machine, and you can see it really good in this one. Here's that Filabot, and then it goes through the sensors to make sure that the diameter is good, and then it hits the rollers that can actually pull the filament to the proper diameter, and then it starts spooling. So like that's a good visualization for us. That's kind of the whole process. Now these are good to make, but they're also tricky to make, right? Because like Stig said at the beginning, like I try to avoid chemicals that I don't need to breathe in, or again, paraphrasing, I don't enjoy breathing in stuff I don't need to either. So when we make this kind of stuff, we have to be mindful again of like how hot are we going to get it, right? So if let's say, for example, this stool is made out of PLA, well, we have to extrude our PLA, right? Like we're talking 200C, maybe 210, right? So that means I have to heat the plastic to about 210. And if you all have worked with it before, you know that if your hot end is just dripping or something, and then you say, hey, turn off, I'm done with you, and then it stops dripping and you go to like pull the old filament off, if that's under 170, it doesn't come off anymore, right? Like it's fairly quick and fairly immediate that it starts cooling. So this is not like a resin casting, although ironically speaking it technically is resin, but like when you're pouring and molding these plastics, you have to heat them, and then you have to make sure that you pour them quickly into the mold to finish it very, very quickly, so that by 10 seconds later, when it's actually cooling and hardening, you're set, right? So those are things to keep in mind when you're making stuff like this. I've seen people put PLA into the oven to make like sheets and malleable tiles and stuff like that. Just again, we talked about it before. I'm gonna throw it out there one more time. Hot things, hot. Ovens are made to heat things, and they're not a sophisticated control when it comes to how hot and how cool they get. So if you put PLA in the oven and you say, hey, I want my PLA at 70 degrees just to melt it a bit, it's fine. Well, your oven's going to fluctuate more than 10% away from that, and then you're going to run into some issues, right? So like it's the same reason why when we're cooling our PLA, dehydrating, not cooling, that we use like dehydrators, because they have a better heat control and can more accurately manage that process. So we've kind of talked about filament extruders, and here, let's take a vote. I'm interested for everybody that's here, that's been chatting. How many people think this is the answer to sustainability in 3D printing? I'm going to reuse all my filament forever just by doing this over and over. So how many people think this is a great idea, this filament extrusion? Is it the answer to sustainability? I'm wondering. Just while we're waiting for that question to come around, you really need PID controller if you want accurate temperatures. He's not wrong. That's you're not wrong at all. That's why they exist, right? PID with a thermocouple, or a thermistor, right? Or that's why they're on our printers. So Gary T says probably not, and I don't disagree with you. And I think I think this kind of like highlights kind of, let's say, like the global problem. We all want to, like, everybody wants to be sustainable. We want to make sure that we're green, right? Right now in Canada, it's, we're talking like, hey, maybe we should all drive EVs by 2030, and then they push it back and then bring it forward. And like, at the heart of the issue, that sounds great, right? An EV technically doesn't burn fossil fuel. Awesome. But like the coal plants and everything else that burns the fossil fuel to get to the electricity you put in, to that car, right? The battery smelting, all that stuff goes into that carbon footprint. And so, like, again, we all have the best intention. So like, and Stig says it too. You can't recycle plastics forever. They degrade. They do. They become unsustainable. The material becomes too weak to be actually, like, we've probably all printed material that's just crappy from the get-go that we've bought new, and that's probably recycled stuff. And then he brings up the point, no matter what, you're going to need virgin material, and he's not wrong. Let's see here. I like that, Stig. That's sustainability right there. Stig just said that the over there, the trucks and buses run on cow dung. I love it. And food scraps. So this 3Devo guy that we were looking at, it's actually requires that you use some of their pellets mixed in with your recycled material. So like Stig says, that virgin material has to be there in order to add the strength and make sure that your filament is strong enough. But again, like, do I feel bad about printing? No, not in any form. Yeah, we actually had biogas for a while. Some of our cars had like little stickers on it that says you could use this if you want. I don't think it went very far. But so when I think about sustainability in 3D printing, honestly, and Gary said it too, I'm leaning towards this isn't the answer. Okay, this definitely will make you feel better because you're doing something, and it's a cool project, right? Like, this is a really cool project. I think that if you're in it, hold on, I'll get back down there. If you're in it at this do-it-yourself level, I think this is a fantastic project to get in on, like in a school, right? It kind of lets you program all the parts. It's just great. Is it going to be sustainable? Well, no, because if you want to print something and you're out of filament, and then you got to do this, like, it could take literal days for this to actually extrude enough filament for your project. So, that's the other problem with sustainability, is people don't want to lose time for sustainability. Now, I'm going to do a thing because it's been a while since I've done the thing, and I should do the thing. Boom thing. No, hold on. Now boom thing. Thank you again, guys. Everybody on here is amazing. If you haven't joined patreon.com/3dmake it, you can go check us out. There's some free stuff. There's some not free stuff. There is the workshops. We're almost done planning for, and they will be out probably. We'll be doing, I want to say around in December, probably at the end, like after Christmas, between New Year's, kind of is our hope. But congratulations, Patreons. You are our guinea pigs for this. And if it works out well, it'll be a good hangout for us all. So there's one more thing that I would like to show in this vein of sustainability. And this one... This one really, it shows the best intentions of possible, but well, you can be the judge. It's this thing, and I think Greg talked about it when it first came out. But basically, what it does is instead of you taking those pellets and dropping them in the hopper from your scrap material, it's taking a bottle. And is there a good picture of it? I know you guys have seen it. So it takes a bottle and it cuts it. So it basically cuts the bottle, goes through the filter, and then it goes down the line to become this PLA. And you can see here that the intake for the bottle kind of wraps around this like feed spool, this geared pulley, and then the bottle gets pulled through this filament sensor, through the guide, onto the spool, and all is good. Let's see if we can PET. Oh, well, apparently my wife's package got here from Amazon. Sorry about that, y'all. Let's see. Someone bottle. Is at the front door. I know somebody's here. Just sorry. I should really turn that off when we're doing such things. Yeah, here it is. So the bottle gets shredded, and you can see this one has a manual process. So he was just pulling it through the thing, and then he's throwing the feed on, and then he's feeding it out to the geared, and then this rolls your filament. Wow, we're living in the future, right? Here's the thing. I'm not saying that this... oh, did I lose it? I must have lost my original link. Okay, yeah, there we go. Go back one more. Or maybe close my search. Boop. Yeah. I'm not saying that this wouldn't work. I'm saying... is it better for us to take in North America, and I'm sure out where you are, Stig, and is it better to take this bottle to the recycling depot or reuse it as 3D printer filament? So what's more sustainable, right? What is the better call there? And I don't know the answer to that one. I can tell you that this process had that manual component. So you're pulling stuff through, and then as you're pulling stuff through, you have to wait for it to get extruded onto the spool, and then you have to, it looks like in this process you're respooling it too. So this is one tier above, maybe grinding the PLA and then throwing it into the system. But I feel like this as a sustainable option, maybe in a region where they don't recycle bottles at, like you take them to the depot and then they repurpose them back to the plants, or they repurpose them into other things, right? Like here we try to recycle like old tires even and use it for bedding for playgrounds and stuff. Yeah. And we do that too. So here, like, and I think the States has the same program. It's been a while, but like, you know, you get 5-10 cents depending on the bottle. You take them back, you get some money, you feel really good about yourself because you got money and they tricked you into being a nice, sustainable person. They didn't trick you. You do it because you're a good person. So taking the bottles back, I think, is better where that's available than turning it into PET or PET. The reason is because when we get virgin materials, so when we're printing and we order a spool of PET or PETG or PETT, whatever, those materials never were something else, right? We don't have to deal with impurities in the materials that might make the print fail. And in this case, I think it's more sustainable to not have your print fail so that you can print it correctly the first time or maybe the second versus a recycled material. As you guys know, PET is actually a little bit hygroscopic. So it's one of those ones you got to keep dry. And this whole rig, you're going to have to like do it all and then dry it and then print. But like when you look at this whole process, there's not a lot of control for like moisture. I mean, you could. This is just like, you can tell like this is what It looks like a 2x6 and everything's just kind of screwed to the top. So kudos on the simplicity of that design. And I'm not saying this is a terrible design, but I'll use the same comment I did last time. It's better to recycle if you can normally than try to reuse it as filament. There are filament companies out there that already offer recycled filaments, so you don't have to do the work. There are some of the filament companies out there that will take your recycling material as long as you've sorted it and then work with it to remake filament, right? And like it's becoming more and more common where these recycled filaments are on those spools as well. So the answer here I want to say is at the manufacturing side of things, where they can take back those materials and work with them properly to get you a product that works properly, that continues your chain of printing in a sustainable way. Let's put it that way. Yay. So I'm not saying these are bad. I'm just saying, like, again, these are great projects and thought experiments if you want to do them. It's just like, even from a efficiency standpoint, though, this will be slower than just buying your filament or buying a recycled filament to keep going. Would I build one of these? Yeah, I would. I mean, how many people would build one of these just to, anybody in the crowd? Would you build one? Would you build one of this one? I mean, I sure would. It looks like it would, at any rate, be a fun little project. And if it worked, hey, you can print a recycled filament thing once a year and say, hey, look what I built. So, I mean, we saw it at the beginning of the COVID thing. 3D printing community stepped up and said, hey, there's not enough of these mask holders. There's not enough of this equipment. And we can sustainably print such things and keep them going in the meantime. And we did that. We couldn't have done that if we relied on stuff like this, but manufacturers can send filament out to us much faster. And I think we need to, it's kind of a scary statement when you think of other industry, but I feel like the 3D printing industry is a little more, they're a little more accountable. That's the word I'm looking for. They're a little more accountable when it comes to the environmental impacts of products. Not all of them, obviously. I think we can all think of a few off the top of our heads that probably just, their machines turning out product for all of us to buy. Let's see here. Catching up on comments. We return to get money. We don't produce filament here in Norway, so what should I do? I mean, it would cost a lot to send filament and scraps and these, and yeah. And that's the thing, right? Like, there are companies, and I know there's 2-3 in the States, and I think there's one in Canada out east now that will remake and reuse the filament. But for for you to ship it, Stig, I mean, yeah, that'd be crazy. And so, like, in your case, like I said before, maybe since there's nothing else, at the very least, this might be a little bit better than throwing it away. Something like this bottle turner or the other extruder. But I think it comes down to, also, you could buy the Polymaker. They have like a sustainable series and print with it, PETG or PLA. And I mean, that way, you know that the manufacturer is being responsible and you're being responsible. Yeah. And so I don't disagree with the, how do I send it if there's no one local? You can't. Right. And we see that all over in different industries too, not just like 3D printing, right? Like I used that Dominican example with the bottles. There's no plan. They throw it in the garbage goes to the landfill, poof, that's it, right? I mean, you could, I don't think Prusa has a local one for recycled filament. I don't think they do recycled, but I think that conversations like this that we had today are important. I think that as makers and 3D printer enthusiasts, we can actually initiate that change, right? Like if you, I know you used to have a local filament guy. Stick, I forget what the, was it Smile? Was it, I forget what the I forget who the person was, but like we can have those conversations, you know. Like we know we've had a filament company on. Like maybe that's a good question that we could pose to them. Like, hey, why can't I send these? And the company we did have on, they actually like say, hey, if you send us back the spool, you know, we'll give you discounts and spool it out. And that's another little cost that saves on sustainability. Um, Yeah, and Stig says you'll need a local producer that, if returning scraps to be economical, definitely. Gary, it sounds like filament manufacturing is unmet need in Norway. Maybe. Whoa, I love that. So Stig just needs some backwards. um, Print with Smile is the name of them, and they make really good filament. Yeah, and I mean, I'm not saying like the right answer is take a picket sign out to the company. By no means am I saying that. I'm saying conversations with these manufacturers, because lots of them are open to like an email that says, you know, hey, I got all this old filament and I don't know how to dispose of it. Do you guys recycle it, or what would, you know, and you can ask and start that conversation. But I think manufacturing is the first step to the answer of this, not like filament recyclers that we looked at. Ray says, and speaking of, hi Ray, the biggest problem with recycling film is you don't really know if it's PLA, ABS, and yeah, and that's where it becomes our problem, right? And there's no way. So like, let's say manufacturer A agrees to recycle filament, perfect. It's not like gold where you can heat it up and the impurities come up, right? Like, no, you melt plastic and you get plastic, and that would be a problem, especially at a manufacturing level, and that would be accountability on us, right? Then, like I said, that bin right now gets everything, but like to be sustainable, maybe I need another bin, right? Maybe two bins. What do I print? Does this farm only print PLA? Then I know, but even then, once you've printed the plastic, you've actually changed the chemical structure in the plastic too, right? Because the plastic passes through your hot end, and your hot end has imperfections in the copper or stainless steel that leave deposits of other material in the plastic. So, I mean, again, that's why you have to mix in virgin material with your recycled material. So there's no way of 100% recycling this stuff. And that's the same thing with any, like, especially ABS. Like, we've been using that for years in plumbing and like PEX tubing and like all sorts of things, right? All that stuff is not recyclable. It will sit in a landfill once it's done. And I mean, that's the human predicament. But I'm saying on our part, there are manufacturers that are trying to be greener. You know, the spoolist or the master spool has been around to get rid of the spool. There's companies now that will recycle filament into printable filament. So, I mean, are we getting there? Are we trying? Yeah, I think as the 3D printing industry, we are trying, right? We are doing our best to be sustainable. I think a lot of it has to do with how a lot of the makers and hobbyists in this field are geared too, right? Like, we don't want to throw away our printers. We'd rather modify them to make them work again or better or differently, right? We don't want to waste stuff. We have boxes and boxes and boxes of bins of parts that you'll never use again, but we need them for that one thing down the line, right? So I think as most of us in the hobby keep such things, and especially people that actually like work as technicians, and repair something, people, right? Service folk, like we're just used to keeping stuff so that if we need that odd part, we have it. And so I think lots of us are already doing a very good job at making our little area of the world, like in our maker rooms, sustainable. But I think it's a conversation we need to have a little more. And I know the title was kind of, I was going to call it like sustainability and 3D printing, but who wants to watch that? You know what I mean? I think it's an honest conversation that we need to have. And I think there's a lot of companies out there in the 3D printing space that are on board with that. I know there used to be a couple in Edmonton, but sadly they are no longer in Edmonton, if you know what I mean. They're gone. Let's see. Dominic says, I would gladly use Master Spool if it was more widely adopted by manufacturers. And I agree, right? That was the... I watched a whole thing on that. But like, there's a Master Spool that you print and it like clips together and screws, and it would be great, but not everybody uses the Master Spool, right? Like if you buy an Esun re-spool, you have to use that roll. If you buy a Polymaker re-spool, you have to use their re-spool roll. They're not all using the same things. Stig says, as an ex-industrial mechanic, I know about saving stuff for later. Actually, it has saved a day a few times and a lot of money. And that's the thing, right? Like this... the value of some of those things that you can save. Now, granted, of the two, there's always going to be the other side of the coin of all the stuff you save, you never used it, right? But there is value in saving like that little bit of thermistor wire or that part that you might have thrown out. Like, oh, I got a broken wheel, I'll just toss it. Well, save it, and then you can put another wheel on it and just like pop the bearing, right? And so it's one of those things where and I like the comment Gary makes, filament roulette. Absolutely. Absolutely. As a manufacturer, you could never guarantee the filament coming back is what you expected, unless you like, science the whole thing. But I mean, when it comes down to it, like I said, manufacturers, some of them have their recycling programs. We're doing our best as makers to get along. And really, I feel if we can print responsibly, that's really where sustainability comes in, right? Like, I have stopped printing, a billion little Benchies and tchotchke things. Like if somebody specifically asks for, hey, I want this gecko or robot or whatever it is, I'll print it because they want it, right? And frankly, there's no difference from me doing it than them wandering down to like a store and buying it. The same footprint exists, so why not me, and why not have fun? But like, I will try to practically print stuff. That's not said that I don't print fun things. I do. It's just in a time where filament costs are going up and we have to be more accountable. I mean, we have to look at all of those things together on how we print and why we print. I'm going to do a thing. Thank you to everybody on this list. I think I updated it correctly. You're all amazing. Again, patreon.com/3dmakeit if you want to join in the fun on the Discord and see all the snowy pictures from Calgary. Ray says, at Spool, we save all our bad electronics, wires, boards, bed, you name it. We may use a piece to fix something. And that's exactly what it is. Like, so where I work, we try to reuse all of our recycling before we send it to a recycler. And we have a lot of recycling, like literal tons of recycling that goes out of e-product, right? And so we do our best to reuse and sustain. If we lived in a communist utopia, there would only be one filament, probably PLA. So recycling. You should write a book about that. That would be great, right? A dystopian future where PLA is the only plastic. Coming soon. Well, I hope you guys enjoyed this morning. I sure had fun talking with you guys, rambling on about sustainability. I think it's something we need to bring forward. And I think most of us are responsible adults and already are sustainable. So I thank you again for coming. And I'll see you next week. Just a quick note. Next week will probably be like our Patreon jammy jams for the month. So we'll have our restream going, and I'll send a link in the Discord. And yeah, I mean, we're on Discord, like Stig says. We can keep it going and keep the ideas flowing and see what we can come up with. But until next time, I gotta bounce. That's why we started a bit early. So you guys have been great, and I'll see you guys next week. Bye.